Hello and welcome to today's webinar, Building Financial Models in Python Using Datastream Web Service. My name is Alison and I work for the Solution Consultant team in London. I'm joined today by Jonathan Legrand, also in London, and Anders Johansson from our Swedish office, and we are pleased to be delivering this webinar on Datastream Web Service today. First of all, some housekeeping. We will be recording today's session. At the bottom of your screen, you'll find multiple widgets for you to use. All are resizable and movable, so feel free to move them around the screen to get the most of your space. If you have any questions during the webcast, you can submit them through the Q&A widget. James Bright, our Datastream Web Service Product Manager, is manning the Q&A, and we will try to answer your questions during the session. However, if we run out of time, they will be answered later via email. Please know that we do capture all questions. We will be using interactive polling during today's session, so it would be great if you do participate. Our additional materials are available in the resource list. Please download those that you may find useful. You can find out more about our speakers via the Speakers Bio widget. For the best viewing experience, we recommend closing any programs or browser sessions running in the background. This will help conserve your bandwidth. The webcast is being streamed through your computer, so for the best audio quality, make sure your computer speakers or headset volume is turned up. Some networks cause slides to advance more slowly than others, so logging off your VPN is recommended. If your slides are not progressing, pushing F5 on your keyboard, or Command R for Macs, will refresh the page. We value your feedback, so we would love you to complete the pop-up survey at the end of the webcast. An on-demand version of this webcast will be shared in the next few days and can also be accessed using the same audio link that was sent to you today. So first of all, you know where we're from. Whereabouts are you joining from today? Okay, so I'll give you a few seconds for that before I move on to the answer screen. So let's have a look at that. Okay, so wow, majority from Europe, some from others, and from the United States. Well done for getting up nice and early for us. So let's move on to the agenda. I'm going to start by giving a very quick introduction to Datastream Web Service. Jonathan Legrand, one of our developer advocates, will demonstrate monthly GDP estimation and information demand use in predicting indices. And then Anders Johansson, one of our product managers, will talk about constructing a chain-linked price index. So, time for another quick poll. So, how familiar are you with Datastream? So this gives us a kind of good idea, get to grips with whether you are completely new to it, have dabbled a little bit, or are a real sort of power user. So I'll give you a few more seconds to get your answers in on that. And let's have a look. So brilliant, we've got a good spread there, some advanced users, and also pretty much something on every level, so brilliant. So for those of you that aren't familiar with Datastream, I'd like to talk about the huge breadth and depth of data that is available. Datastream is one of the world's largest historical financial databases. It holds over 400 million time series, including 35 million individual instruments or indicators across all major asset classes. This includes over 14 million active economic indicators. It features 70 years of data across 175 countries, and recently we've added a subset of economic series which goes back to 1900s. Datastream gives you the information and tools you need to interpret market trends, economic cycles and the impact of world events. Unique content includes IBIS global aggregates, WorldScope fundamentals, economics point-in-time data, and Reuters polls. Datastream can be accessed as a data feed, integrated into Icon with a Microsoft add-in for dynamic updates, or via Datastream Web Service, known as DSWS for short, so you may hear us refer to it as that during the webinar. So we'll be looking at this Datastream Web Service today. So there are two types of license available for users depending on your approach to Datastream Web Service data. So if you are using data solely for your personal use, you will have access to the desktop service. So this is a capped service, allowing you to access up to 10 million data points per month. This is included free of charge in your subscription to Icon DFO, Icon RNA, or Premium Datastream. However, I will point out that you do need to be permissioned before you can start using this. So please do contact your Refinitiv representative or customer service to get this set up for you. The second type of license is if you wish to redistribute data internally or access more than 10 million data points per month. And this is where you will use Datastream Web Service for enterprise use. If you do have any questions on how to gain access to Datastream Web Service, please do use the chat and we can help advise you. So I'm going to share my screen with you now. So let's just click that on. It does take a few seconds to click through. So whilst we're waiting for that to appear, I'll tell you a little bit about Datastream Web Service. So there are dedicated Python, MATLAB, eViews and R extensions available with Datastream Web Service. But today, it's a pleasure for me to introduce you Datastream Web Service via Codebook. Codebook is our new integrated Python scripting environment available through Icon or Refinitiv Workspace. And you can find it simply by searching Codebook in the Icon search bar or the Workspace launcher. You'll notice a familiar Jupyter-like interface. Key difference is that we're shipping it already with a whole host of libraries and extensions that you can see here. The benefit is that you won't need to install anything on your local machine, hopefully circumventing any IT security issues that you may experience if installing them independently. In the examples folder on the left-hand side, there is a really useful notebook containing a large variety of sample code. You'll note the reminder at the top here that you do need to have Datastream Web Service permissioned if you aren't already. The top line imports Datastream Web Service, and here is where you need to enter your Icon username and password, and you need to do that for every workbook that you create. I'm going to show you a couple of lines of code now, just to give you a bit of taste. I'm just going to make sure I am on presentation mode. Okay, that's good. So what we have here is a notebook. I've got very simply at the start a simple code lookup. So what we've got here is our ds.getData. In the tickers, this is where I'm going to look up the MSCI world. So this is my sort of text search. And then we've got in the fields where you'd normally put a data type, we've got the DS symbol lookup. So let me just authenticate this. You can see here we've got 10 options back. We can increase that, or you can specify specific asset classes as well. So we've got the MSCI World here, which is what I was looking for. It came out top, so that's good. We've got a couple of lists and some sector indices. I will say if you are looking for something that is less common or maybe economic data, you may want to use the Datastream Navigator, which is the code lookup that comes as part of DFO or Datastream charting. It is also available as a standalone URL, which we'll put on the resources that we send out at the end. Within Navigator, you get the ability to filter down through the data much more and also use the explore functionality to sort of drill down through the folders and see what data is available. So the next request we're going to look at is what we call a static request, or a data point. Again, we've got our ds.getData. We've got the code that we used from above. And for my fields, I've requested the 12-month forward enterprise value from our IBIS Global Aggregates database, our 12-month forward net debt, and then our 12-month forward sales as well. And at the moment, because we haven't requested a date, this is giving us the current data. So this is our snapshot effectively. But if you did want to put in a specific start date that you wanted to see the data from, you can just enter it in here, like so. And now that's bringing me those values at the 1st of January 2018. My next request is a time series request. So this is very similar to our snapshot. Again, we've got our ds.getData. We have our start date and an end date and a frequency as well, so quarterly here. For your start date, you can use a fixed start date like I did with my static request, or relative using days, months, weeks, years, and so on. Here I have my Chinese GDP ticker, and I'm using data from our economics point in time database, which is one of my favorites because it really sort of shows what helps move the markets. And here we have our first revision, the date of that revision, the second revision, date of that revision, and third revision, and so on. So you can kind of really get an idea as to sort of after the initial release, how that data changes. And we can see here, looking at the first line, you can see that GDP here is sort of generally being revised upwards. It's a really useful database there. The last request that I have here is looking at MSCI sector performance. So this is a list of tickers. So this is our MSCI World, energy, materials, consumer discretionary sectors. I've got my time series request here. So again, I've got my ds.getData, my list of tickers, and in my field I have X. So X is the default data type on Datastream. If you're looking at economic data, it just brings you back that value. If you're looking at equity, it brings you back price. If you're looking at an exchange rate, it will bring you back the mid rate. I've got my start date and my yearly frequency. I've got a couple of lines of code, and then I've got my static request here, which is just going to bring me back the name of each of these sectors so I can put them at the top of my request. And so here we have our percent change, our yearly percent change on the MSCI sectors here. So we use Python here to create our percentage change and to transpose the data. But just to advise you that on Datastream we have over 80 functions available that allow you to manipulate the data from regression, statistical analysis, through to sort of rebasing. So they are definitely well worth a look. And you can nest these functions together to create more complex expressions as part of your analysis and reuse those time and time again. So the last thing I'm going to show you is just on this right click, you can create a new view for output. So what this does is puts it onto an output screen. I can just minimize this. Because I used my code book in a layout, I can now have my DSWS data running through my layout alongside, my Datastream charting, my MacroX app, and so on. So you can incorporate it as well into your desktop. So that is a very quick look at sort of the nuts and bolts of Datastream Web Service. I am now going to hand over to my colleague Jonathan Legrand, who is going to be talking to us about GDP estimation and information demand use in predicting indices. So over to you, Jonathan.
Oh, thanks, Alison. That was brilliant. Hi, everyone. My name is Jonathan. As Alison said, I work for the developer advocacy team at Refinitiv, and today I'm going to be going through I'm going to go through 3 articles that you can find on our developer community portal. But first of all, I have a question for you all, because I'd like to know to which extent you actually know about our about mathematical manipulations in general. So I'm just going to leave this question here for 30 seconds, asking you how proficient are you with mathematical and statistical concepts, such as ordinary least squares methods, otherwise known as OLS method. Is normally one used for optimization methods in econometrics. The reason I'm asking for it is, depending on the answer, I might spend more time on one article rather than the other in this webinar. Okay, let's move swiftly onwards then. Okay, that's good. All right, so I'll move on more to the estimation of GDP rather than the ESG stuff, but I'll still speak about both. Okay, let me just share my screen. We'll see how well that works. By the way, before we get going, I'd like to apologize first of all for the speed at which I'll be speaking. I have quite a lot to cover, so I hope it's not going to go too quickly. All right. Just waiting for the screen to share. You can find all of our details on the Refinitiv developer community website that you can see here. And I'm going to be speaking about 3 articles that you can find on this website, as well as one that is on GitHub only. The 3 first in question are going to be on Python, and the last one in the language R. All right, so moving swiftly onwards, you can have a look on our developer community website, and you can find it on developers.refinitiv.com. And up there at the top, you'll have use cases. By the way, you'll have all of the resources given to you by email after this webinar. Here, you'll have the academic landing page within our developer community webpage. And here you'll have a little blib about what we do. And at the top right, there are 2 articles that I'm going to be talking about today: estimating monthly GDP figures via an expenditure approach, and the same one, but computed via an income approach and using the Holt-Winters model. So these 2 are quite econometric heavy, well, more so than the other one anyway. But the first that I'd like to speak about today is actually using Datastream to find sustainable development goals for country scores. Just to give you a little look at what we're going to do in this article, we're going to rank each country as per their ESG scores. So you see it goes from the top of Monaco out of 10 all the way down to which one's it's in Somalia. And then we're also going to create an interactive graph. Okay, so this is what you can find on the developer portal. It's just a static article. I've actually made a little quick video, a 5-minute video that goes through the entire article. And in this article, you can just Google Datastream Sustainable Development Goals country score Refinitiv, and this will come out on the top on Google. And if you're interested in the background and the code, I'm going to be going through it right now in Jupyter Notebook as opposed to Codebook, just for this very first example. If you want to follow along and work with us with your Jupyter Notebook, you can go to the source code at the top right of the article. If we just have a look in there, I already had it open, and you can click on download the code, download zip, put it somewhere where you can find it again. If you save it, and then if you I think you have to extract all, and then double click in there again, and you'll have your IPYNB file, and that's your Python Jupyter Notebook file. Okay, I've already got it open on my computer, and we're going to be going through this Datastream Sustainable Development Goal Country Score article. What we're going to do here is that we're going to use ESG data, which is to say environmental, social, and governance data, to rank countries as how they do with these scores. All right. First of all, in order to do so on Jupyter Notebook, you'll just have to import your data, your libraries. We're going to start with math, statistics, and NumPy, as well as pandas to manipulate our data frames, so the tables that Alison has already showed you kind of just before. And we're also going to use Pickle. I'm going to go through what that is. But the most important and the star of the day is going to be Datastream DSWS. So I'm importing it as DSWS so that I don't have to write the entire name every time. And I am using a little trick here whereby I have a text file for the username and password for Datastream that I'm using. So I've just gone to the location of where I'm running my file, which is here with the green dots. And above it, you can see my username and password in text file. And this native Python function called open allows me to go to this text file and just retrieve my username and password right there. The reason I'm doing this is so that I don't have to share it on the screen in live editions like this one, but also so that I can share my code with anyone without them having all my credentials. So this is what this cell does. Then I authenticate myself with this Python object that I'm calling ds as dsws.datastream with my username and password. And we shouldn't forget also to close our text files that we've opened. All right, moving swiftly onwards, we're going to use a certain number of other libraries, including NumPys. We've already spoken about pandas, and OpenPyXL is only there for manipulating Excel files if you want to output Excel files of the data we're going to get. Okay, we're also going to use datetime to manipulate time. Okay, I'm not going to go through too much of the defined functions, but this point function we're going to get back to in the future. First of all, Alison thankfully went through already quite a lot of how to collect data on Datastream. So instead, I'd like to show you how one may try to collect a great number of mnemonics data on Datastream. A mnemonic is just like a ticker. And here, what I've done is that at the location where I'm running my script, I also have a CSV, that stands for comma separated value file, and that's an Excel file. Now, do tell me if you can see my Excel file. I'm showing it on the screen. And here you can see that you have a mnemonic for each of the metrics, the ESG metrics that we're going to be looking at. So 1.1.1 happens to be the metric for, I don't actually know what it is. It's the proportion of population below the poverty line. Okay, so that's what this one is. And we have a mnemonic, which is, say, a ticker on Datastream for that information for each country that we have information for in the world. So it starts in Afghanistan and goes all the way down. And what I've done here is, in Python, I'm collecting all of these mnemonics and putting it into a data frame that you can find here. I've called the data frame df, and I'm using this. I'm calling columns in a way that is useful so that I can recognize which column is assigned to which metric. And I'm going to call for each piece of data, as you can see here, for each code within the CSV file that I've imported in my Python environment. So here, I'm doing in batches of 50. I've left quite a lot of comments for you to have a read and understand what's going on, but I'm doing it in batches of 50 because that is the maximum amount of data you can get from Datastream. And so we're going through quite an awful lot of data. Let's have a look how many metrics are there. There are 154 metrics. And in total, there are 32,500 mnemonics for which we're going to ask for time series data. So that's an awful lot of data. So instead of going it through manually, I've done a little loop here for you. And here it is. Once you've done it, I've called my table, countries values table, and you have a look at everything from Afghanistan all the way to Zimbabwe for your metrics in ESG metrics. I've spoken about Pickle. Pickle is a Python library that allows you to collect your data and save it inside what is called a byte file. A byte file is literally nothing but zeros and ones. Now, everything in a computer is nothing but zeros and ones, but this one is specifically raw in that it only stores the specific data that you're asking about. In this case, the Python objects that I've defined right there. The reason I'm doing this is because the code that I've written above collects so much data that I'd like to keep it within my computer whilst I'm running my script and my code, because if I find that there is an error somewhere, I'd like to go back and not have to call all of the DSWS data every time. It takes about 10 minutes for me at home. So what I've done is I've saved it in a pickle file, and in order to load it back again into my script, all I have to do is use this cell here where I'm using right here, pickle.load. Okay, I've already done all this myself, so I'm not going to save and I'm not going to load anything. I've run all my cells in interest of time. And just to delimitate the two parts between when I've called the data and when I haven't, I'm just calling my data countries values table 2. And then I'm doing some mathematical manipulations. Sometimes I'm not interested in the metrics themselves, but I'm interested in something else. So for example, here I'm interested in the ratio between two matrix. metrics, not matrices. And that's the case for more than one metric. So for example, 1, 2, 3, 4, 5 of them, I have to do a simple manipulation. Most of the time it's just a ratio. Here it's the ratio of a product. I'm not sure what each of the metrics stand for. But following onwards, I am then going to collect my data that is normalized in the way that we've just gone through. And then, yes, I'm going to apply a polarity. Now, if you had a keen eye when I showed you this table, you noticed that on the left to the top, you could see that there was a polarity table right here. And what it shows is that for each metric, it's given it a polarity. So metric 1.1.1 was this one, if you remember, which was the proportion of population below a certain poverty line. And you know that the more people are below the poverty line, the worse it is. And therefore, it's given a negative polarity. And let's have a look at a positive one. What's that? 1.3.1. That's the proportion of population covered by social protection. Okay, so it's some kind of insurance. And you can see that the more people have this social protection, the better it is. And so this metric here, 1.3.1, which is right there, is given a positive polarity. And what I'm doing here in this cell is I'm collecting the polarity for each of the metrics. You can see them here, negative for 1.1, positive for 1.3.1, and I'm applying it to the data. And that's what this cell does right there. I'm then going to concatenate everything into one table, which is what this cell does right there. And I'm going to rename my metrics. Instead of 1.1.1, I knew that that was no poverty, and it goes all the way from no poverty to partnerships for the goals in general. And I'm going to concatenate everything, put everything into one data frame, which is what this cell does, and there it is. So you can see here it goes from no poverty. And we're going to have a look at the scores available. Now that's very important, because some countries may have an awful lot of data on the metrics that we're talking about, these ESG SDG metrics. SDG standing for social development goals for each country. So here, for example, Afghanistan is actually really good for the no poverty in terms of recording data. It's got 9 out of 10 metrics that we collect data on. So we can be quite assured that this medium number here that I'm using to calculate how well Afghanistan is doing is actually quite accurate. We know that this is, I mean, it might be a low score, but it's an accurate score. Whereas in other countries, let's have a look at the American Samoa, for example, it's only collecting 1 metric out of 10 that we're recording when it comes to no poverty. So here we're going to disregard this piece of data. We're going to say we're not sufficiently confident in the fact that this one metric encapsulates the entirety of how American Samoa does in terms of no poverty. And we do this for all the metrics in question, from zero hunger here, where we have 7. So sometimes the more scores there are, the higher the threshold is. So here, for example, we have 15 metrics, and if it's less than 6, we discard it. And we do it for all of our ESG scores, all the way to what we find here overall. The cell above this one, what it did is that it created an overall column which aggregated all of the scores together. You can see that we are keeping the score available ratio here in order to understand how many metrics are taken into account into the calculation of our medium. And we have a medium score for all of our countries. You might be wondering why medium and why not mean, and that's because we're trying to not to not let huge numbers distort our calculation here. For giving you an example, if Sweden is doing extremely well, or if the US is doing extremely well in terms of ESG data, then it might skew its data when it's in terms of no poverty, but they might have very bad, I don't know, water quality or something as such. And we don't want it to be drawn too much just because of one metric that might be very, very good or very bad indeed. So we're using the median points instead. Scrolling onwards, we're then going to try and chart our data. I'm not going to go too much through this because we've already gone 10 minutes through this. And we're going to plot our data with matplotlib. Matplotlib is a Python library that allows you to plot static data. So here you can see that if I'm moving my cursor on it, nothing changes. But it's quite good because we can see all of the countries and all of their scores in a score out of 10. I've normalized everything out of 10. You can see as we scroll down, we can see all of the scores. But I've also used Plotly for an interactive graph. And you can see here on this graph, I can zoom in on any part that I'm interested in. You see, for example, if I just want to see these top ones, and we've organize things so that they are only in quarters. So you only move in quarters. So you have 8.5 here and 8.75. The reason is because we don't have that very many ESG metrics for each country. So we don't want to give a false perception of precision. Now, I'm quite confident that these numbers are accurate, but they may not be that precise because there isn't a million ESG metrics per country. And so we've decided to do it this way. Lastly, but surely, if you would like to output all of your data into an Excel sheet so that you can then have a look at it yourself and do your own graphs in a more malleable manner, you can do so right here and output everything in an Excel sheet with this cell. The Excel sheet that will be coming out of this will look exactly like this one right there, with the header, for example, sustainable cities and communities, and the subsetters, the scores available and medium points, as well as all the data frames that we've had this far. Okay, moving swiftly onwards, I'm going to be showing you how one may use Datastream to estimate GDP, monthly GDP, via an expenditure approach. All right, in this article, what we're going to do is we're going to try and estimate monthly GDP data when only quarterly GDP data is actually published. To do so, we're going to use Codebook this time. And if you'd like to access Codebook on your browser, that's completely fine and possible. All you have to do is go on icon.thomsonreuters.com. You don't need the index.html. If you don't put that, it will put it in automatically. Once there, you can go on Refinitiv icon web access and sign in right there. That's what I've done. And then once I was in there, I just went on Codebook in the similar way that Alison has showed us. And I outputted my code right there. Okay. To estimate monthly GDP data, we're going to use the common expenditure approach of computation of GDP, which is to say we're going to, by the way, if I didn't explain what GDP was, it's gross domestic product, which is largely said to be the calculation of the wealth of a nation. I'm not going to go through the conversation about how accurate of a metric it is, but this is just what we're going to be doing today. And we're going to use this equation to compute GDP. C plus I plus G plus X minus M, where C is consumption, I is investment, G is government data, X minus M is your net exports. This is the most famous computation for it, and it's the one that's normally used by the Bureau of Economic Analysis in US Department of Commerce. Now, I've added links, and these links are, by the way, in the article itself. So if you were to click on there, it sends you directly to Datastream, to the portal that Alison has spoken to you about, and to the data, so you can have a look at it and have a look at the details. So for example, here, this is the USA GDP figures given, and you can see that it's only published on a quarterly basis, not on a monthly basis. Going back, I wanted to show you actually what it would look like if you were to log into the portal on Datastream. All you have to do to log into that portal, apart from using the links that I've showed you, is go on product.datastream.com. You will be greeted and asked to put your credentials, and you'll have to just scroll down and go to series at the bottom here. And then it will send you to the correct location so that you can have a quick look at the data that you're looking for. All right, moving swiftly onwards, then we're going to be having a quick look at how to encode this method. We're going to be using Datastream, and I've used the exact same trick here to use a text file to collect my username and password to authenticate myself. I'm going to use the same technique that Alison has explained to get data. And here I've done it for a USPER so whatever that is. Let's have a quick look. If I go on my portal, I can put that in, and it's the personal consumption. So this is the consumption part of my GDP calculation. And you can see here that consumption is released on a monthly basis. Now, it happens to be the only component of the summands of GDP, the summands being these things here, that is released on a monthly basis. All of the others are released on a quarterly basis. The fact that C is released on a monthly basis is great. It means that we're going to be able to extrapolate more information about this. I'm going to skip through the importation of libraries because we've gone through it before. And through there, what I've done is I've defined some functions. Again, we don't have much time to go through all of them right now. I've done some that will plot some graphs as well for you. Okay. Moving swiftly onwards, then we have our consumption data, and we also have some quarterly data. Something that I wanted to show you was the fact that this monthly data was calculated and taken in when it was published on the 15th of the month, every month, and that may be a problem. We actually may have some summands that are published on the 15th of the month, others on the 30th of the month, and things as such. And what I'm going to do as a result is I'm going to normalize everything so that it is done on a first of the month basis. So when you see a data frame later on, it might show you that it is on the first of the month, just because I've normalized things myself. We're going to collect all of our quarterly data, going from investment, government spending, and net exports. And then we're going to have a look at everything put together. You see here, I'm using the add to df, which is a function I've defined above, to normalize all my data to the first of the month and add it to my data frame. And having a look at my resume here, I've graphed things, and we can see that the GDP component sum, so the sum of all of the summands that I've imported above, is in purple here, and the published quarterly data for GDP is in brown. And you can see in the graph, I don't know if it's big enough for you, it should be, you can see that you can hardly actually tell the difference. You can't, they seem to be overlaid over each other, and that's a good thing. It means that we're using a technique that seems to be accurate in predicting or estimating the published GDP data. Okay, you can also have a look at the data frame itself. Here it is. I've just called it DF. And scrolling swiftly onwards, we can have a look then at the estimation method that we're going to use to try and interpolate monthly data. Okay, we are going to use the Holt-Winters model here, and I'm not going to go through exactly the intricacies of each mathematical function that I'm going to use because we don't have the time, but I have found a great Medium article that goes through this. So if you click on it, even on the article itself, it sends you directly to this page that goes through not only the mathematics, as you can see here, but also it gives you really good examples of what you can do with your Holt-Winters model. The Holt-Winters model basically only just takes into account the most recent data with greater weight than the data from previous days. That's the gist of it. There's more to it, but you can go ahead yourself and have a look and tweak all of this. By the way, you can copy and paste the entire thing and tweak it yourself and have a look at what you can do. And I'd be very happy, by the way, for you to do so and send it to us. We have a competition going so that you can send us your articles and you might be published on our webpage. I'll go through this at the end of my webinar. And here I have created a function that goes through the Holt-Winters model for the data that I've taken in. Okay, scrolling quickly through it. What I've done here is that I have done a Holt-Winters estimation, monthly estimation for investment. Now, I'm going to be doing a Holt-Winters estimation for each of the components of GDP, of the summands, consumption, investment, government spending, and net exports. But what's interesting here is that in this article, we are able to do some interpolation on a monthly basis without waiting for the new figures coming out. What does that mean? Well, if you are interested in knowing what the GDP data, the GDP figure for the US should be in February, if you were to just interpolate what the February GDP data should have been based on the published figures, you're going to have to wait until March, the end of March, when the quarterly GDP figure is released. Now, that's not much use. Maybe at the end of February, you'd like to know, well, in February, what was the GDP data? Well, what we can do here as a result is actually use a Holt-Winters model prediction, with an estimation actually, on a one-period basis. So for example, in February, I will try and have a look at what is in February, and in March. And we're going to be very heavily using the consumption data to base our assumption on. But here, for example, we're doing the exact same thing on investment data. And we can see here that the investment model fit, which is in orange, is very, very heavily, basically, again, overlaying the blue data, which is the released data. So you can see that it's doing extremely well. Also, I've shown you a little bit of a forecast. Now, it's way too long of a forecast. I would never use I think it's 2 weeks or maybe 2 months of estimation right there. But the reason I wouldn't use this is because normally it's just one period ahead. So sorry, we're doing months. So this is probably 10 months or something as such. And you can see that it's going down, and that's because it was predicting COVID-19 getting worse on an intermittent basis. Scrolling down, I'm doing the same for government investment, and I'm doing the same also for net exports. And we can have a look at all of our data right here. Okay, now let's say we've got all of our components, and we were to add them together to try and figure out what it is on a monthly basis, but we'd like to maybe know how well we've done. So here is a cell that does a back test for our method. Scrolling quickly, we can see here that I'm trying to test my method going back from 2007 onwards with all of the investment data right here. And you can see that it's doing quite well. So let's say that I did not know what the GDP data was at that point, and I'm looking back at how well it's done. You can see that the orange line, which is our model predictions, is always going through the steps of the blue line. The blue line is in steps because it's released on a quarterly basis, and the other one is on a monthly basis. The same thing is done for government spending and net exports. All right, swiftly, I'd like to move on to the same article that looked through not the expenditure approach, but the income approach this time. It's a bit more math. This time I'm not going to go through all of it. If you're interested, you can write there for it. And it goes through the mathematics and the concept of using the income approach as opposed to expenditure approach of the computation of GDP. But scrolling through, we don't have to go through too much of all this, but this is going to be more related to the question I've asked you at the start. So I've created quite a lot of functions, Python functions, for example, ones that plot some graphs on 2 axes instead of 1. But more interestingly, here's another one. We're going to be looking at not the estimation of GDP per se, but actually the real GDP per worker. That's why you can find some things. And here it is. This is the OLS regression for this method that we're using here. So here we're not using Holt-Winters, we're using the OLS regression. And I've made a little Python function here that you can take and copy and paste yourself if you want to use it to plot on a graph. And you can see that this OLS regression is not doing quite so well. It's just a straight blue line, and you can see the released data in orange. There's quite a lot of gaps everywhere. And it didn't even compensate for COVID-19 once it happened. So I wanted to compare this to the Holt-Winters model, and scrolling down, we can see that this is the error. There we go. We can see here that it's doing an awful lot better. The R is the ratio that we're predicting through the mathematics here, and it's doing an awful lot better. It's compensating for COVID-19. You can see that the variance is quite high. It's higher than the blue line, and that's because the intermittent data is a lot higher, monthly data as opposed to quarterly data. Okay, I think I might still have literally 1 minute to go through my last article, which is coded in R. This time you can actually find this piece of work if you go on the Refinitiv developer community on the use cases, and then if you go in the academic landing page, if you scroll down, it starts to say source code. And there is a link for information demand and stock return predictability. What this article does right there is that it uses Google Trends data to try and, inside a Gauch model, so if you don't know what a Gauch model is, a nonlinear variance model, it tries to use Google Trends data to predict the variance of any index, any stock index in question. So I've done it here with Google Trends data for the number of times people Googled the word S&P to try and figure out if the variance of the S&P 500 would change too much in the next time period, so tomorrow. And I'm using this variance prediction to try and find out if the S&P 500 is going to go up or down tomorrow. And throughout this whole thing that is coded in R, I'm using Datastream data. And if I scroll all the way down, you can see how well my model is doing. This specific article goes through how you may do so both in parallel computing and in series computing. It took 3 days for this to run in series computing and only 3 hours, less than that, parallel computing, so it's quite useful. You can see here which model does best. SVR standing for the search vector index, which is from Google. All right, I spoke about the fact that you could submit your own article if you have an idea, maybe a Jupyter notebook, and you've had a look at everything we've done here, and you've noted that, oh, maybe the estimation is not the best, and maybe you'd like to have a multiplicative Holt-Winters model as opposed to an additive one or something as such, and your model did an awful lot better than mine, then by all means, please do tell me. Have a look on the academic landing page, and if you scroll down, you'll find the Refinitiv academic article competition. If you click on there, you'll be sent to a form where you can fill in your details and submit your work. Okay, I'm just going to have a glass of water. I've been speaking quite fast and quite a lot, and I'll hand the mic over to Alison. Thank you so much for your attention this far. Let me try and end this.
Thank you, Jonathan. That was brilliant. We do have one question about the GDP seasonality model. So sorry to fire one at you while you're probably gasping for a drink. The predictions are promising. On what period is the model? On what period data is the model trained on?
So it's trained on, that's a very good question, actually. That's very, very good. Okay, so the model itself is trained via Holt-Winters model, which means that it's only doing it on a recursive basis. And I've showed you the results for this recursive basis from 1950 all the way up to today. But remember that every single time it happens, it's only using past data. So my model is not training on the entirety of the data set I have. As a matter of fact, if you really dig into what I've done, you'll see that at the very start, it's doing extremely badly because it's got very little data to base itself on. It's actually just saying at the start, oh, tomorrow's GDP data or next month's GDP data is going to be the same as today. It's that bad. But then as it learns, as it goes through from 1950 to 1951 all the way to 2007, by that time, it's already quite a lot better. So when you look at the backtesting part of what I've done, what that does is that it says, if I was an investor in 2007 using this, how well did it do from 2007 to today? Which means that the model was already trained from 1950 to 2007. That was the training period for the very first point in the backtest. I hope that answers the question. I think we might have lost Alison, in which case we might go on forward.
Sorry, on mute.
So
on the GARCH model, what was the model training period and the testing period window? Is that the same as for the previous one?
Oh, okay. No, the GARCH model is an awful lot more complex. I only had 2 minutes to show what it was. It was recursive as well. In the same fashion, but GARCH model doesn't work the same way as the Holt-Winters one does. You need quite a good time period even for your first data set. And I don't actually remember how long I took. I think I took, was it from 2000? So it would have been maybe 10 years of data. 2000 would have been 1990. I think it started in 1990 to the year 2000. And then all of the rest of the testing I've done, I think, is from the year 2000 onwards. Do have a look yourself. I don't actually remember the exact date, but it's something as such. So about 10 years of training data for the GARCH model. And then again, from there, it's done on a recursive basis. So it's every day since the year 2000, how well would an investor have done if they were to have invested in the S&P 500 when the model told them to? And it's doing better than, a hold, buy and hold and other such methods.
Sure. Brilliant. Thank you, Jonathan.
By the way, sorry, I forgot to mention, in this whole method, we're only looking at excess returns. So only if it's better than holding the best bonds for that month, every month.
Great. Thank you. Right. Anders, over to you now. So I think you're starting with a poll, Anders. Is that right?
Yes, hello. My name is Anders Johansson, and I'm one of the product managers for Datastream. And I have a polling question on what type of data you're using. Is it, if it's financial data, if it's intraday or daily, or if it's macroeconomic data or something else?
I was a bit slow with the poll, so I'll just give that a quick second, Anders, before I release the results for you.
Yes.
Here we go.
Okay, so I have one example of each here, and I will use a code book to show how I can construct a chain-linked price index. And it's used by statistical agencies around the world to measure inflation. One chain-link short-term price indices to account for changing consumer patterns over time. And here we have a standard formula for that. But This can also be used to create a stock index or portfolio return index, such as MSCI indices. I will use Datastream Web services to download data and Datastream functions to simplify the workflow. Here is an example of a Datastream function where it looks a little complex, but well, I use yearly weights and download it from Datastream. It's Eurostat data, and transform it to monthly because the price indices are monthly. And there's a link to Datastream functions here, which opens in a separate window. And as we have seen before, use pandas and the Datastream Web Service interface. To download data. And here we have, well, the country weights and setting it up to use further calculations, and can take a look at the average weights since 1997 for the Eurozone countries. And I download short-term price indices using a cumulative product, which is restarted every year. So you get yearly short-term price indices. We can look at inflation, average annual inflation during this time period, and download the official price index from Eurostat. And then actual code for constructing the chain-linked price index. It's fairly easy when data has been pre-arranged. Simply have to multiply the weights with the price indices, and set a start value at 100 and update every year, end of the year, so you can create the chain links that way. And the replication works quite well. As you can see, then the difference is mainly random, so it's due to limited precision, essentially. So this is how the Eurozone consumer price index is constructed, basically for the aggregate consumer price index. The second example is to create a return index for a portfolio which can contain all the stocks in the FTSE All Shares at the end of last year, and it's rebalanced every quarter. And I have one example of market value weights and one with equal weights. And I use a static request to download the names in the index. Is this list of constituents. Then I create a long string, which I can use in the time series request. Here I use an expression for creating a list, and some manipulations to get the market values at the end of each quarter. So I pad those values over for the whole quarter. And here is take a look at the weights for yesterday. Well, around 20 stocks have died during this period or ceased to trade. And the way this is handled here is to, let them eventually get zero return and disappear from the portfolio at the end of the quarter. So it's a kind of underestimate of the performance. And a normal investor would go out earlier from those investments. And quarterly short-term price indices or return indices here, dividends are included. And but I create a function so I can use the same expressions for both the market value weighted index and the equally weighted index. So it's quite simple and very similar to the earlier expressions for the consumer price index. But here I have quarterly rebalancing instead. So I update the value each quarter. And here I have the result. It seems, you can see the effect of the COVID-19 crisis. The equally weighted fell more than the other ones. But it also bounced back, so it's almost back at what it was at the start of the year. That's quite interesting. And some descriptive data for the indices and their returns. And they are quite highly correlated, as one would expect. Almost perfectly correlated, the market value weighted and the official index. And here are the latest values for which confirms that the equally weighted index is almost back at the start of the year. Okay, that was my presentation.
Thank you, Anders. Another great one. Thank you very much. So this brings us very close to the end of the webinar now. We have had a few people asking about the libraries within Codebook. You're not able to add to those yourself, but if there are any libraries that you would like added, please do let us know either via the developer portal or by contacting us. And we can get the developers to add them. So hopefully that answers your question. I don't think we had any other outstanding ones that we haven't answered, but we've had some very good feedback, so thank you very much. We would love to hear more from you with regards to the survey that will pop up at the end. Will be the recording and all of the resources will be sent out in the next few days if you do want to refer back to anything or listen to anything. But all that remains to say is thank you very much for your time, and we hope you found the session useful.